All right, number 1. Jensen, let's read.
Find the area of a regular hexagon with 10
Okay, let's see if y'all recall. Only in a regular hexagon, the radius is the same thing as one side. I think my pen's running out. Okay. Jack, can you help me? Will you take this off? Put it on this. So go ahead and write the area of equilateral triangle on your paper while you're waiting on me. And go all the way to the edge where the pen cap starts. Awesome. Is that enough? Okay. Thank you. Okay, let's draw the hexagon. Okay, if I draw my hexagon, you might recall as if I'm making a rectangle and make your dots, and one to the left and the right. If your neighbor's not paying attention, tell them, hush. So only in a regular hexagon, we have 6 equilateral triangles. So according to my equilateral triangle formula, it is side square root 3 over 4. This pen might not work also. And we know one side is 10. So if I have 10 squared root 3 over 4, all I need to do is type this piece in. So isn't 10 squared 100? What is 100 divided by 4? 25 radical 3. But how many of these do I have? 6 of them. So we're looking at 150. Is that right? 6 times 25? 150 radical 3. And we're looking at feet squared. This is only allowed if you have a regular hexagon. For all the other shapes, we have to kind of do a reminder of trig. This pen is not going to work out. All right, Jack, will you help me out again? Okay. Transfer. I think I wrote too much. That's okay. Okay, while we're waiting, Anna, let's read example number 2.
If the apothem of a regular hexagon is 7 centimeters, find its perimeter and area.
All right. If I am giving you the apothem, you cannot use side square root 3 over 4. So let's go ahead and draw our hexagon.
Does this one work before I...
Yeah, it works. Jack, you're like, is this worth it? Thank you. All right. So my apothem is going to be your center to the side that is perpendicular. That is our apothem 7. So if I have my 7, let's go ahead and find out how many is this whole thing. But that whole thing is the same as x because of the hexagon, right? Are we all following through? So what we're going to do is, I want you to make similar triangle. Only in a hexagon we have 30, 60, 90. Any questions on why 30, 60, 90? The central angle is 60. Half of that is 30. 30, 60, 90. And if you recall the ratio, it was 1 radical how many? 3 and 2. So let's go ahead and do, what do I need? 2, what do I know? And then I have x root 3 is equal to 14. From there I have x equals 14 root 3. And what was the rule when you have radical in the bottom? You multiply by the root 3 to get rid of the radical. So I get 14 root 3 over 3. Now you have to ask yourself, can I further simplify 14 and 3? No. Now that right there is 14 root 3 over 3. So let's see if y'all recall the area of a regular polygon. Apothem times perimeter divided by 2. Wasn't the apothem given as 7? Now this is going to get kind of fancy. I have how many sides in a regular hexagon? Okay, someone type in 14 times 6. 84? Is that right? 84? So 84 radical 3 over 3. All divided by 2. So Mark, will you give me orange number 30 calculator? Now you guys might think, well, there's too many things. We have something called a magical calculator. So type it in exactly I have on my screen. Okay, everyone type in 7. Everybody, open your parentheses. Jensen, stay with me. The radical 3 I'm not going to mess with. So I have 84 over 3. Alpha y equals 84 over 3. Are we all there? Do we all see where the numbers are coming from? And then I press enter. My last thing I need to do is divide it by what? 2. Boom, so 98 radical 3. Notice I left it in terms of the radical, because we don't want to round as we go. And that value is going to be centimeters squared.
Wait, did you put a square above the root 3?
That's from divided by 2. That's from right here.
Oh, okay.
So if I give you an apothem, you have to use AP over 2. Alright? So let's look and see what number 3 looks like. Spence, let's read. Could we volume up like by 10? It's like, Alexa, raise the volume by 10, right? Can you read it one more time, please?
Find the area of the pentagon beside this set.
Okay. I know I'm not going to be good at making regular pentagon, but I think of house. So let's make our triangle here. Here's our apothem. So the apothem area of a regular polygon with a side length of 7. So this is telling me this is 7 right here. So could I go ahead and say this is 3.5? All right. I want you to write on your SOHCAHTOA. It's a good reminder. That's okay, it's a reminder. So what I want you to do is take this triangle and then zoom into it, just so that's easier. So we have this triangle is 3.5. Okay, everybody on your calculator, type in 360. How many central angles do you think I would have in a pentagon? 5 sides, right? So we know it's 72 for this whole thing. But if I want half of it, divide that by 2, it's going to be 36. So what I am looking for is my apothem. And let's write out the formula here. Area is equal to the apothem times perimeter divided by 2. Apothem I do not know. Go ahead and leave that in parentheses. If I know one side of the pentagon is 7, and 7 times 5 is how many for the perimeter? 7 times 5, 35. So as long as I find this x, which is the apothem, we're good to go. So let's see if y'all recall SOHCAHTOA. Hypotenuse is here. Which is my opposite, the x or 3.5? How many? 3.5, and that's adjacent. So according to my rule, I need adjacent, I know opposite, so it must be TOA. So tangent of angle 36 is equal to our opposite over the, adjacent. Y'all remember the rule when the x was on the bottom? Swap. And let's make sure our mode is in degree mode, and mine happens to be. So we have 3.5. I should do alpha y equals, 3.5 tangent of 36. And it says to round to the hundredths. So how about this? Since I don't want to round as I go, I'm going to round it to the thousandths and then round at the very end. Does that make sense? You make it more detailed at the beginning and then make it to the actual decimal. So 4.817. And let's type that in. 4.817 times 35, enter. And take that number and divide it by what? 2. So we have 84. And that is our area. 84 point how many? 3. Because that 9 is going to go up by 1 more, which is 10. And it's going to cause this to be 3. If you want to write the 0, that's fine. You don't have to. Inches squared. Anna, what's up? You don't have to though. But if you want to show me, hey, I know my decimal places, might as well.
Okay.
All right, I want you to re-explain this problem to your neighbor real quick. Go. Bigger scissors? Are there bigger scissors there? If you open my drawer, there should be a one with the black handle. But put it back in there for me.
Maya, why did you hear this? Like at least 5 people have said it looks darker. It looks more like pitch black.
Of course. She's trying to be like me. Can't help it. Thank you.
Hey, you spot the short.
Kyle, the center drawer. Center drawer. Open it. Oh. Do you see it?
Can you re-explain how you got 36?
36 on here. So if I have a pentagon, we know we have full 360 in the central angle. It goes around. And in a pentagon, there's 5 central angles. But that's for the whole thing. But I was cutting it in half. So half of that is 36. Because 72, Mark, is pertaining to this whole thing.
Okay.
Okay? All right. For regular octagon, let's start by writing our equation to the area. Everyone write that out. Because I'm not going to draw the octagon. I can draw up to a hexagon. I can't go any further. All right? So, are we all there? So it says area of a regular octagon with one side. How many sides do I have in an octagon? So if I take 6 and times 8, that means our area is equal to sum apart them. That means my perimeter must be how many? 40 how many? 48 divided by 2. So all you need to find is the apothem. So I want you to draw me a big triangle. Here's the apothem. And I know this one side is 6, meaning half of them must be how many? 3. So now let's go ahead and get our calculator. 360 divided by what for the central angle? 8. That's for the whole thing, but I need half, correct? So divide that by 2 is going to give me 22.5. So could we do opposite over adjacent again? So we have tangent. Oh, Jack, it might not work. 22.5 is equal to our opposite over the adjacent. Can we swap the order again? Is that a yes? 3 over tangent of 22.5. And that's going to give us some decimal, but let's make it one more decimal place. If I lost you, tap on your neighbor, please. So I'm going to say this number is going to be 7.24. How about 3? Are we okay with that?
Yeah.
Okay? You want to keep it as 2? I'll go ahead and put 2. You were joking. So funny. So we have, that's a 7 by the way. 7.243 times 48 divided by 2 is our final area. So I know at first you're like, ooh, that was pretty hard, but now you're like a machine. So inches squared. So it looks like finding the apothem, we're always using sine, cosine, or tangent. Tangent.